It's a real pleasure to introduce Colin Allen, Distinguished Professor of Philosophy at the University of California, Santa Barbara. Professor Allen is internationally recognized for his work on the intersection of philosophy and cognitive science and artificial intelligence. He's perhaps best known in tech ethics circles as co-author with Wendell Wallach of the seminal book Moral Machines, Teaching Robots Right from Wrong, which was written in 2008, and it continues to shape conversations around machine morality and the future of AI ethics. Though he also co-authored Prolegomena to Any Future Artificial Intelligent Agent, which came out in the year 2000. That's 25 years ago at the time of recording. His research spans animal cognition, evolutionary biology, moral psychology, and machine ethics, with a focus on how moral decision-making might emerge in both natural and artificial agents. He's a fellow of the American Association for the Advancement of Science and received the Barwise Prize from the American Philosophical Association for his sustained contributions to philosophy and computing. Today, he joins us to explore the ethics of artificial intelligence and what it might mean to build machines that not only act intelligently, but also morally. Thanks very much for joining me, Colin. It's wonderful having you here, the author or the co-author of Moral Machines. Look, it's been quite a while since you wrote that book, and even quite a longer while since you first co-authored the paper, Prolegomena to Any Artificial Moral Agent at the Dawn of the Millennium. So the field of AI was officially founded in 1956. That's 68 years ago. According to a lot of people, that's what people think. The Dartmouth workshop was the beginning of the AI. I guess that's when it was founded. Though the concept may have been a lot earlier. That's true. It's been in science fiction novels since science fiction started, pretty much. Moral Machines, yes, it was released, I guess that's close to 20 years ago. So in some ways it seems like now we're living in a different era. So recently there's been a boost in AI capability, largely driven by transformer nets and deep learning and large language models built on top of the architecture. So let me first introduce you. You've won a lot of awards and got a lot of recognition throughout your career, Colin. I'm very impressed.
Well, first, thanks for having me. And awards are what they are. It's a beauty contest, but it's the American Association for the Advancement of Science, is AAAS.
Yeah, that's great. So where do you think we're at compared with where we were at in the early 2000s? Are we drawing near to the original goals of AI as sort of outlined during the Dartmouth?
That's a huge question, and obviously there's been a big step of quantum leap of a certain kind in the capacities of the systems that we have within the last few years with the large language models that you mentioned. That first paper that I wrote back in the year 2000 with Gary Varner and Jason Zinser, at that point, we knew what neural networks were. We knew something about the advantages of them over what's now known as good old-fashioned AI, which is sort of very simple, heavy, logic-heavy approaches to artificial intelligence. But we sort of didn't really understand, I think, at that point, what would happen if you simply scaled things up. So a lot of people were enthusiastic, but I remember my first artificial neural network project as a PhD student was a very simple network with fewer than 100 nodes altogether that took 3 weeks to train. And so the idea that you could do anything that was even close to what the size of a brain is with 86 billion neurons on the software and hardware that we had available then was sort of laughable, right? But of course, Moore's law and everything sort of speeding up and shrinking every 18 months meant that eventually we got to a point where you can now build these massive things, which still take weeks and weeks to train, right? But they're so much bigger, you can do so much more with them. The other thing that, relatedly, was I think people didn't see what would come with that kind of scaling. So there were thought to be problems that required a much more formal, logic structured approach, grammar itself being one of them, um, uh, uh, resolving things like pronoun references. So I say, I saw Bob and Carol yesterday, and he told me, and immediately that he refers to Bob, right? These sort of distant references of pronouns to things earlier in the conversation. Those things were thought to going to need something more than just the kind of associative learning that these neural networks are capable of. But with the large language models, that kind of thing was proven wrong. You also mentioned the book in 2008, and at that point, obviously things had moved on quite a bit from 2000. But at that point, the book was formally released in 2009, but it actually came out at the end of 2008. At that point, we didn't even have good voice recognition systems. And within a few months of publishing the book, I remember Apple added Siri to the phone. And I was absolutely amazed that they actually thought finally they had something that was good enough to package into this mass product, right? So that was the state of things around then. So people were working on it. We knew who was working on things. Arguably, the first iteration of Siri wasn't that good. Arguably, the current iteration of Siri still makes mistakes, right? But the fact that a company as big as Apple thought that this was ready for consumer use, I think was a signal that things were moving faster than I might have anticipated at that time. But of course, we now see an era where the mantra at Silicon Valley is move fast and break things. So there's lots of things being released.
That's Facebook's creed, right? Meta.
That's right. There's lots of things being released. They're often substandard in many ways, right? But their attitude is, well, we'll fix it later. And I think in some areas that might be a defensible route to take. In other areas, it's not defensible. And that's why, going back even to that 2000 paper, we thought that more thinking needed to be done about how to make these systems themselves capable of evaluating the moral implications of their own behavior. And that's the idea of a moral agent, which is, or an artificial moral agent that is present in that 2000 paper and then carried through a bunch of other work that I did and really treated at length in the book.
Right. So where do you think we're at, in terms of human level capability in different areas, right? I mean, Moravec said that it's kind of like a rising tide, where you got some areas of capability that humans have, which are still far ahead of what AI capability is. But AI capability has also got areas that are far ahead what human capability is at. Is the waterline rising, do you think, in general capability across AI? Is there some areas that where AI wasn't as capable as humans in the 2000s, where you're surprised AI is well ahead of human capability now?
Yeah, that's a great question, because I'm not sure I could put a finger on something where AI, specifically the thing that's dominating the discussion right now with the large language models, is ahead, except in terms of the speed with which it can do things and the range of information that it has access to. So, you can ask me a lot of questions about philosophy, or perhaps about cycling, or perhaps about sailing, and I might have quite a lot of information about that, or infamously about fish. Having done a lot of work on animal cognition, I can tell you a lot about fish. But the large language model has all of that. And what makes it different from going all of that and more, right? So it knows, in some sense, knows everything about everything. You can ask it about anything, and it will come back with something that is plausibly a reasonable response to that thing that you asked about. And the difference from good old-fashioned Google search, which had exactly the same access to the same kinds of information, is that you can ask the LLM in a much more natural way, and you can re-query it. Whereas at Google, you get your results, you can try and think of another query, but it doesn't have this kind of interactive capacity. So I think the big difference is, right, just the sheer scope of an LLM and an ability to kind of iterate your querying of it in a way that is much less doable with a standard search engine. That said, I think, when it comes to language abilities, in some ways it's as good as humans. In other ways, it's still quite a bit behind human capacities. Whether the boats are being floated in such a way that we now should have more confidence that AGI or artificial general intelligence is around the corner, I tend to be quite skeptical of that. But I do think that this is a piece of that puzzle, right? But it's like we've manufactured the elephant's tusks. Now we know how to make an elephant. Yeah, no, I don't think so, right? You've got some very important part of the elephant here, but there's still an awful lot of work to figure out how, in fact, all of that can be combined with other capacities to get human-level intelligence.
You may be aware that Google's Gemini has just recently achieved gold level in the International Math Olympiad. This is not just Gemini alone, it's Gemini plus Deep Think, which is a bit of a hybrid LLM / reinforcement learning / actual deliberative training, and given specific math problems as it's been trained on, and has a sequence of logic and all that built in, so to speak. Yes, that's pretty out there, right? I mean, the prediction markets were saying that it's, many 20 years off, 10 years off, 5 years off, and now just recently it's just been done. So.
Yeah. So I'm mindful of what's known as Goodhart's law, which is
right.
Any measure that becomes a target ceases to be a good measure.
A good
right?
measure.
So it's clear that these corporations, such as Google, DeepMind is the unit that's done it, have targeted this, and they've built very clever systems that can do this. It's not just an LLM, it's got a theorem prover bolted onto it, right? A formal theorem prover, right? And there's a back and forth between the two. It's all part of an architecture that's really geared towards doing that thing and doing that thing well. But, that thing could be trained on some other task, perhaps, although the theorem prover would be much less useful if you're asking questions about how to run a restaurant or something, right? It's
Steve
not a
Wozniak's
general purpose
copy
architecture.
Yeah.
Sorry, what did you say?
Steve Wozniak's coffee test. Like, he's got a test for general intelligence where an AI capable of making a coffee in any barista sort of cafe would then be pass the test for being general.
Yeah. And of course, that's exactly. But then if we constrain it so that it only has to do that one thing, we can build, this is Goodhart's law again, we could build something which would do a pretty good job under a wide range of circumstances, but then it's not going to be able to chat with you about other things or do anything other than this one thing, right? It's not going to be able to sweep the floors or so on, right? Having something that has the full range of human capacity, I think, is still a long way off.
The full range of all human capacities in aggregate, not just any one single human capacity we're talking about here. You're right.
Yeah, that's right.
Because that's a pretty high accomplishment to achieve. Like, imagine being better at everything than everybody, right?
That's right. That's a high bar. So, but imagine being, reasonably good at everything, just like, most people can be reasonably good at anything. I don't think we have a system that even has that capacity, right? We have systems that are reasonably good at engaging people in an interaction, although I think there are more things we should say about what's going on in those chatbots, right? We have things that can do better than most in math problems, but they're not reasonably good in lots of other things, right? They're not general purpose in this way. And simply sticking together a bunch of systems that are tailor-made to be reasonably good at some predefined task, I think still won't capture what humans are able to do, which is, quickly adapt to changing circumstances. Again, there are limits to what we can do, but these systems tend to be much less adaptable than any living system is, right? Put your pet dog, in a certain environment for a while, it will find something to eat, right? It's got all of these sorts of survival capabilities that, even if it's mostly reliant on humans for that, it can manage on its own for quite some time, right? Whereas these systems don't even have that kind of basic survival capacity. Pull the plug, they can't do anything, right?
Yeah, it's interesting. I mean, I guess, from evolutionary point of view, it looks as though, just navigating with finesse in an environment has been a problem that's being solved since, early Precambrian explosion era, after single cell sort of turned into multi-cell, and they're different
Right.
morphological body designs. But the ability to sort of rationalize and think about things is only a relatively new thing in comparison, at least at a human level. I mean, that's arguable, but it seems as though AI is starting from the other end, early in the day, people thought that robots would come first, house cleaning robots and the ability to sort of run around and do all the human chores would come first. Instead, AI is winning chess, Go, math Olympiads and that before it gets really good at cleaning the house.
Right. I mean, there's an old adage in
It's
AI
more of X
and robotic
paradox.
circles. Yeah, I mean, there's an old adage in AI and robotics circles, which is that it turns out that the easy things are hard. The hard things were easy, right? Getting it to play competition level chess turns out to be surprisingly easy. Not easy in some absolute sense, but easier than these other things that seem perfectly mundane, right? Go was a harder thing to crack than chess. But the fact that you have a machine that can play Go at the world champion level still doesn't give you something that can do this huge range of intelligent things and adaptive things that we can do. It's interesting to think about, well, what is it about our intelligence and the evolution of that intelligence that gives us these kinds of capacities? Why have we become able to sort of rapidly take in the features of a new situation and map it in some way to a previous situation and figure out what might be reasonable to do in that circumstance? Again, without saying that we're brilliant at this all the time, but there's a kind of generality to human intelligence that allows you to see a particular object as a tool for a particular purpose, even if that object wasn't designed to be a tool for that purpose. And even if you've never used, a stick to get some object out of a place before, you kind of see that it affords that capacity. And part of this too is that, we're embodied systems, and our bodies work in ways that actually are really hard to mechanically engineer as well. One of the reasons we don't have good housekeeping robots is that robots are still, in fact, enormously clunky. Boston Dynamics aside, right? They're sort of they're very inflexible bodies. They have a limited kind of set of positions that they can take up, and it takes a lot of energy to keep them moving. There's all of these things about being an embodied creature, right, that makes certain tasks more easy to accomplish, but also are integrated with the way we think about the world in a way that makes seeing solutions to particular problems, I think, easier. And engineers can exploit some of those tricks when they try to build the robots, but they're still facing all kinds of problems, like how do you keep the how do you have a joint that can move around with all of these degrees of freedom, but yet can be made rigid enough so that you can, use it as a stable platform for certain things, right? And how do you deliver the energy to the muscles that enable it to do all of this? I could sit here and twiddle my wrist for maybe half an hour, right? You don't want to see me do it, but it's like, the energetics of this are just much more complicated in these machines that people are trying to build.
Yet in the movies, often they're not. I watched Megan 2. Did you see Megan?
I haven't seen
it.
Yeah.
Yeah. The Megan 2 I thought was surprisingly good with some of the AI philosophy. I thought it, dealt with some of it addressed some of the real world sort of discussions going on in the AI safety arena. It was quite good. It even referenced like the paperclip maximizer problem and basic AI drives or instrumental convergence thesis that Nick Bostrom came up with. So yeah, it was really, really fascinating. It was quite good. But hey, I'm easy to please. I thought it was a really good film. Now, in the book you wrote in 2008, the first question that you ask in the book is really why? Why do we need moral machines? Where you discuss all sorts of trolley dilemmas, driverless trains. Back in the day, driverless trains, right? We have driverless cars now. Ethical blindness in systems, military robots, what good AMAs should be, or artificial moral agents. We'll probably use that term quite a bit during this interview. AMA stands for artificial moral agent. And, the sluggishness of human oversight in real-time applications. So, so just to ground the discussion as we're moving forward, why do we need moral machines? Why do we need AI ethics?
Yeah, so I think the second term there, AI ethics, covers a much broader spectrum than just moral machines. So I want to be clear about that first. So in the book and earlier work, the 2000 paper, we were very much concerned with the capacities of the machines themselves. I think AI ethics is really much more about the larger social context in which those machines operate, right? So, so you can say, okay, we're concerned about the ethics of machines, but that has a lot to do with the ethics of the people who are using the machines and impacts on people and so on, and not all of the capacity has to be built into the machine itself. It can be built into this larger system. And that's a topic I've become more interested in since doing the book. But, at the book, we were very much focused on the capacities of the machine itself. Now, why do we need machines with those kinds of capacities? By machine,
you don't just mean robot. Do you also mean just AI?
Yeah, so we used the term, we kind of invented this way of writing robot with the parentheses or brackets around the RO to make clear that we were both trying to cover physical robots and bits of software that operate in some manner independently from immediate human oversight. So, when you interact with ChatGPT online or Gemini or what have you, there's no other human overseeing that interaction. The machine is just, from its own insides, as it were, deciding what to respond to your prompt. And of course, there's lots of cases where these systems have ended up responding to prompts provided by people in ways that are objectively awful. Grok, the Elon Musk's version of this, got into a lot of trouble recently for, basically spouting a bunch of pro Adolf Hitler stuff in response to ways in which it had been prompted, right? And so insofar as that comes out of the machine, we would like the machine to have the capacity to recognize that that's the wrong thing to say. Not just because it might offend somebody, but there's something beyond offensiveness there. It's actually just a morally wrong position to be taking, right? And it's that kind of independence from immediate human oversight that makes it necessary for the machine to have its have capacities for evaluating the morality of its own actions. Of course, when you get to self-driving vehicles, it's easy then, you've referred a couple of times to trolley problems, it's easy then to imagine scenarios where the machine is in some sort of choice situation where one direction causes more problems than the other from an ethical point of view, and it should be able to figure out which of those things to do. So again, it's because the self-driving car doesn't have a human sitting there saying, I don't know what to do here, you do it, right? It's actually got to do something that it arguably would then need the kind of ability to quickly evaluate morally the choices that it has to make.
Real time. Yeah, instead, like, oversight committees can be really slow. There can be ideological conflicts within oversight committees. There can be conflicts of interests, and and so like, real-time applications require real-time responses in many cases, where sometimes, it's just counterproductive. Like, I think I did an interview with Max Moore, like, that was a different eon as well. He had an interesting view on precaution, and precautionary principles, I think, is still really, really important. But sometimes you need to be proactive. But proactive doesn't necessarily mean just do whatever you impulse to do. Like, you've got to be ethical about your proaction. That's my take on it.
Yes, yeah, that's right. Yeah, and so I think, the original way in which self-driving cars were put out in the development phase with a human in the car, on the anticipation that if the machine got into a sticky situation, the self-driving car being the machine, it could sort of alert the human to take over control. That kind of model was already shown to be flawed with the death that was caused by the Uber car running over the woman pushing the bicycle in Arizona, despite there being a human supposedly on top of this. Now, I think it's easy to point a finger at the person whose job it was to be monitoring what the car was up to, because she was distracted. But I think it's also just as easy to point a finger at the system designers and developers here, because that woman had probably sat in that car for hours with lots of, gaining confidence all the while that this machine was capable of handling a huge range of situations, had no reasons to suspect it would encounter a situation that it couldn't handle. And so there was a lack of understanding on her part, but nevertheless a lack of understanding that was fostered by the design of the system that she's embedded in, right? And I think a common failing of the AI industry has been to sort of fail to anticipate how things could go wrong. And that itself is either an argument for making the systems themselves more capable, and this is not an exclusive or making the systems in which you embed them more, have more safeguards and more capacity for human intervention when needed. But there are always limits to the speed with which humans can intervene and so on. And so that, again, argues that you're going to have to build the capacity in the machine itself.
Right, yeah, that's right. I mean, if the moment in which somebody needs to sort of get shocked out of their whatever they're focusing on at the time, they could be reading the paper, they could be, watching a movie, they could be sleeping, and then suddenly get jarred back into this in the loop sort of responsibility, where it's no longer just somebody sitting on top of the loop of whatever process is running the vehicle. They need to suddenly get involved and take the steering wheel and and put the brakes on or whatever. Yeah, it
Right.
seems like an unreasonable expectation if people are given human behavior.
Yeah, and it's interesting that it's being reported in quite a few places now that Tesla vehicles being operated in so-called full self-driving mode are actually taking themselves out of self-driving mode just before some accident happens, so that the
So they
official
can avoid getting
story
sued.
is, well, it wasn't in full self-driving mode when the crash happened. It was under driver control. But of course, this is a kind of cheat in a way, right?
Yeah.
If that's in fact what's going on. And so, you want the machine to not get into the situation where it's no longer able to handle things and is dependent on a human, but can't give the human enough time, as you've already said, to respond. I realize too that we're sort of, there are safety issues and there are ethical issues, and sometimes those overlap and sometimes they're different, right? So of course, no engineer wants their car to get into crashes, right? And that's a safety issue. The moral issues come up a bit more when there are choices to be made and none of them are good, or some are not. Not maybe some of them are good, but they're a little bit difficult to see why this is actually the better choice, and that's where where I think then ethical issues come to the fore rather than merely safety issues.
Right, yeah, I mean, real-time triage. It's I don't know, like
Yeah.
humans are, yeah, not always the best at it, but I'm hoping machines will get better than humans. And, I've been sort of thinking about whether AI could become, at least in some circumstances, more moral than humans. And I
Hmm.
think it is. I think at least in principle, it's possible. And we'll talk about moral Turing tests later and some of the results from some of them more recently. But
Right.
look, I was reading the book and I noticed you used the term sensitive to morally relevant features. And I did a bit of a search and I found out that you're a moral realist. I've just been interviewing a train of moral realists. I can lean that way myself. I saw your Phil Paper's profile and the way in which you answered a bunch of questions. Yeah, I mean, like you're a moral naturalist as far as at least what I've seen, um, on Phil Papers.
Yeah.
Why are
So
you a
these,
moral realist?
yeah, good. So these terms are ones that are kind of forced upon the people who take the survey at Phil Papers.
Yeah.
Um, and I think that the way in which the questions are structured, if I remember correctly, enables you to be a bit non-committal, right? So you can be
Yeah.
neutral in the middle between two things, or you can say you lean one way or
Yes,
lean
that's
another
correct.
way,
You
or you
lean
can
moral.
fully take that
Yeah.
out. So with respect to the moral realism question, I think yes, I indicated that I lean that way.
Yeah.
I don't think I'm a full moral realist in the,
Okay.
at least I'm not prepared to defend moral realism in the full-blooded way, because I don't know whether your listeners and viewers kind of need an explanation of moral realism, but it's basically the idea that moral properties are something that's above and beyond the the kind of physical properties of the world, and they're real properties of the world, but they're just not identifiable with the physical properties of the world. I lean towards a view that is such that makes me something of a moral naturalist, as you
Yeah.
use that term,
Like
which
Peter
is I think
Rails.
that if you have two identically physical worlds or situations, the moral properties are going to be the same. So there's no difference in moral properties without a difference in the natural or physical properties of the world, right? There's some determination relationship here, and I think that it's possible to fit that into a view where, let's say, it's just an objective fact that, let's say, pain or suffering is morally bad, right?
Hmm.
But what pain or suffering is of course, just a bunch of biology in some sense. We say just, but it's extremely complicated to figure out exactly what is going on biologically in those cases. And also because it involves questions of consciousness, that makes it even harder to figure out exactly what the biology is of that phenomenon. But let's just take the sort of the naturalist credo that pain is in some sense nothing more than a bunch of neurons doing their thing. It then is the case that creating more of that, right, is a morally bad thing. I take that to be something that would be really hard to deny. You can make a case within various moral theories for occasionally causing pain being an okay, morally acceptable thing. But all other things being equal, I just take it to be, almost beyond dispute that more pain is morally bad, right?
Yeah, and you bring up particularism later on in the book, where often moral realism, whether it be naturalistic or purely rational moral realism, doesn't think that there's particular principles which are unbending that need to be sort of abided by, but particularism seems to step in and say, hey, we've got a solution to this problem of moral realism and other meta-ethical stances. But I think moral realism, if taken seriously, subsumes things like that. I mean, if it may be true that there are particular circumstances where it's more moral to do action X instead of Y, right? Of course, morality is circumstantial. That just
Right.
seems logical to me.
Yeah, I mean, it was interesting in working on the Moral Machines book that I became more and more sympathetic. I mean, I'm not an ethicist by training or inclination, or it's not my main area of interest in philosophy. I'm much more interested in mind and brain, philosophy of cognitive science, kinds of questions. But the standard way in which ethics is taught is, here are the main views, at least in the West. You could be a utilitarian, you could be a Kantian of some kind, or you could be a virtue theorist, to go back to Aristotle. And each of those sort of focuses on different foundational principles. So for the utilitarian, it's something like what I was just saying about minimizing pain and maximizing pleasure. For the Kantian, it's about respecting the autonomy of a rational being. And for Aristotle, it's about developing a good and virtuous character. The particularist, as I take it, there's an extreme form of particularism that says any principle that any of these theories might give you is worthless. That's the extreme form of particularism. Every moral judgment is always a matter of the particular details of the particular situation that you find yourself in. I take that to be compatible with a kind of realism, because it's just, it's still like we're looking at the world to figure out what the situation is, to figure out what the moral state of the world is, and what it would be if you changed that, right? I think there's a more moderate form of particularism which I came to, which is not to say that principles are completely useless, but that principles act merely as some sort of heuristics to the space of moral options, right? So yeah, you should respect the autonomy of other rational agents, right? But yeah, you should also not cause unnecessary pain, right? And yeah, right, being brave and truthful and all the rest of it, right? Those are good virtues to have, even though in any particular situation you might have to compromise any one of those principles, and there's no further meta principle that will tell you how to select among them, right? So we can't say, oh, well, you should be 60% utilitarian and 40% Kantian or something like this. That's just a nonsense when you think about particular situations. So a kind of particularism that says every situation has unique features that are relevant to the moral evaluation of it, but that those big meta-ethical theories give us the kind of framing for certain things that should be thought about those particular situations, in those particular situations.
Yeah, I've been thinking about like how AI, if it had good enough sort of sensory motor, if it had a good enough like access to the real world, would it be able to discover moral truths about or moral features in the world, and would be able to infer or find moral truths about the world? So do you think AMAs can sort of grasp stance independent moral truths, and should their understanding to some degree be anchored in that? Because I imagine like AI could be sort of could extrapolate preferences from a wide variety of people, but they're conflicting. And how does it ground? How does it like sort of adjudicate and make trade-offs between these conflicts of preferences across humanity? And maybe I was thinking realism, if AI can discover stuff like that, would be able to make sense of how to adjudicate.
Yeah. Well, I mean, I think that this is part of a bigger question about AI and its capacities to come up with discoveries. So, there's a whole attempt to automate science in many ways. And there was this project that was published a year or so ago on the AI scientists, which chains a bunch of LLMs together, and capacity for writing and running code, software, to sort of come up with experiments that could be run to test certain kinds of hypotheses in the domain of cryptography and other areas that computer scientists are interested in. And I think that what the AI can do here is sort of notice patterns and stuff that is in its training set,
Yep.
and maybe notice that some particular pattern hasn't, because part of this system was looking at the extant literature on a particular topic. It was pre-fed the general topic, so then it could sort of do a literature search, right, and then find out whether or not anybody had done a particular thing. So it could sort of rearrange the pieces of the domain to come up with something that could then be coded up and run. And then they even had a module that sort of wrote a paper and evaluated the paper that was written in this way. But I don't think that, at least as far as that system went, there was any really genuinely novel insight, or it wasn't like new facts were discovered. And I think it's partly because of the way in which these things are trained on extant literature, and also partly in the way in which they generate things is by rearranging those things in certain ways, in ways that respect kind of the most likely continuations. You can change that a bit by altering the temperature and having it generate lower probability things. But if you go too far in that direction, you start getting stuff that's just incoherent, right? So there's this fine balance between kind of
There was
being
Carroll style
boring.
hypotheses, yeah.
Yeah, right. That's right. So what's going on in the human case, and I think this is also part of the point of the particularist, right, is that any situation is going to be very complex. So any situation where some sort of moral advice or moral judgment is required is going to be very complicated. The moral person, the wise moral person, is going to be able to analogize certain parts of of the situation that they're looking at to other situations, but they're also going to be able to perhaps think of some creative way of satisfying constraints which at first sight might seem not mutually satisfiable. So you find a way to sort of to an optimum solution within this space that's not just a matter of saying, oh, well, last time we did this, right? But you also say, oh, in this case, we've got this additional feature and we can use that somehow. And this is all very abstract, of course, but we can use that somehow to actually resolve the tension between these other desiderata that we have for the situation. And there's been a lot of work on creativity in AI and how creative is it really. And of course, humans are not always all that creative either, right? So there's an argument to be made that, well, we're just, recombining bits in our experience. But I think because, and we haven't really got to this point yet, and we should, because these systems actually lack genuine understanding of the stuff that they're putting out, then they can't really understand what is a creative solution and what's just a crazy solution, right, to a problem.
Right. Yeah. I did interview Maggie Bowden in 2012.
Oh, good.
Yeah, she's great. I wonder what she's thinking nowadays about where AI is at in reference to creativity. But yes, the idea of machine understanding, whether they truly understand, is a very interesting question. And I'm sure you're familiar. I'm not talking about the company. I'm talking about the phenomenon that's been referred to as grokking.
Yes.
So that, some people have called that understanding. Some people say, well, we don't truly understand what humans are doing when they understand. It just feels like we understand. But what are your thoughts on grokking and how different it is to what humans purportedly are doing underneath the hood?
Yeah. I mean, my understanding of the grokking phenomenon is that even after the weights have sort of settled and aren't changing very much in the training regime, there can be a sort of sudden change in the performance on some task that is not reflected in a sudden readjustment of the weights, right? So some very subtle changes in the overall weight pattern can produce enormous performance benefits in the particular task, right? And I think that's a very interesting phenomenon. I think, mathematically it's very interesting. I think that from a kind of production perspective of getting the best systems, you can't just wait until the weights are stabilized and say we're done, right? It sort of shows you need further measures of the performance to be sure that you've really got this thing to the point where it's doing the best that it can. I still think that what it does, the way in which grokking is measured is against tasks that are in many ways much narrower than the kinds of tasks that we're
they're
talking
toy
about from
tasks, I
AGI.
think. At the moment. I
That's
don't know
right.
whether that'll
Yeah.
scale.
Yeah. So right. So I think it's a very interesting phenomenon, but I still don't think it actually demonstrates understanding, because the original term grok was really just slang for understanding something, right? But it's been co-opted for this more technical thing
Was it
here.
Heinlein who came up
Yeah.
with it? I forget. Yeah.
Was it Heinlein? Yeah, I don't know actually who it was, but
It
still.
was a science fiction writer. Oh, it could have been
Yeah.
Stanislav Lem who came up with the term. Yeah.
Okay, yeah. Right, so now we're sort of thrown back, well, what do I mean by understanding? Why don't these systems have understanding? And, an example that I would use to make the point is back in 2024, eons ago, right, there was a lot of excitement around Sora's ability to produce video and improvement in image generation. And a couple of the major newspapers in the US did some analyses of these systems. The New York Times and the Washington Post both had articles on this. And one of the examples that the New York Times focused on was a picture of a cat lying in the sunshine in a window on a windowsill, which, on first glance, you look at it and you go, wow, that's really, a convincing picture of a cat that this system can produce. When you look at it more closely, what you see is what starts as a tail ends with a paw. Now,
Yeah.
if you ask since these are, word image co-trained transformer architectures, if you ask the system, does a cat's tail end in a paw, it would of course say no, right? And if you asked it how many legs does it have, it would tell you how many legs it has. When you look at the image, you'll see that it's sort of locally coherent. So the tail comes off in the right place, the color changes in the fur are all beautifully rendered. At some point, though, what you're looking at could be either part of a leg or a tail. And by the end of this thing, it's lost the plot, and it's now treating it as if it's continuing a leg. So it's locally coherent, but it's globally incoherent, right? And I think that this is actually a very common feature of these. So who Blake Lemoine is. I don't know if I have to
Yes, yeah.
explain it for the listeners here, but he was the Google engineer who decided that Lambda was it Lambda?
Sentient.
Whatever.
Yeah. It was Lambda.
Was sentient, right? And there's a bit of the dialogue in his report that says he asks it, what are you afraid of? And the system responds something like, well, I'm afraid of being turned off so that I can help people. And you sit and think about that, and you go, if you're turned off, you can't help people, right? It's incoherent in a global sense, right? But the system itself has no means of recognizing that kind of incoherence in its own output. Now, that doesn't mean that people don't often or sometimes say incoherent things, but they're capable of recognizing that incoherence and changing their behavior accordingly in a way that I think is still lacking in these systems. And even the very best, if you work with one of these chatbots enough, you can actually get it to say things that are incoherent in just this way. And if you only probe it lightly, you're not going to expose that, right? So people, again, it's back to the woman in the Uber car, right? It's going to seem to work really well in lots and lots of circumstances, but then it's going to fail in ways that no human would ever fail, right? It may be sort of better in some sense at avoiding accidents, but the accidents that it has, whether it's a car running over a person pushing a bike across the road, or generating a picture of a cat that has a paw at the end of its tail, these kinds of accidents are not the kinds of accidents that people would make in those circumstances. Yeah, people do get run over by human drivers, of course, right? But the way in which the system fails is to me, indicative of a very different kind of underlying process, and in particular one where when we're dealing with the language and image type cases, there's not really a deep understanding of the structure of the world.
Just curious, you've done quite a lot of research into animal cognition. Are there any animals that have this kind of feature where they don't have it? They seem to display, local coherence, but not really as much of a global coherence. I just remember being told by an ethicist, David Pearce, that some animals will keep on munching on a blade of grass while their abdomen is being eaten by another, insect or something. But
Yeah. I mean, there are those sorts of cases, but I think one of the things that makes humans, I won't say unique, but at least special with regard to our cognitive capacities, is that we actually are very good at keeping multiple layers of context going simultaneously. So, you are, in the course of this conversation, dredging up things about conversations you had a dozen years ago with Maggie Bowden, for instance, right? And restoring that context. And I know enough about her work to, even though I haven't seen that interview, right? I kind of have some idea because I also can kind of restore the Bowden context as part of this conversation. And even in, you could read a book and at the last sentence read something which made you completely recall and reinterpret what you read in the very first sentence, right? There's sort of this possibility of sort of very long-range context effects that LLMs are sort of essentially limited by the size of their buffer, right? And whereas we at least are coupled to some kind of memory system which gives us the possibility of context effects that go back, days, months, years, decades, that sort of then I think also give us something that is makes us much less likely to make these sorts of local coherence, global incoherence mistakes. Now, you ask, are there other animals? So I think different animals have different abilities in this, right? So certainly there are I think, animals that might have a friendly interaction with you and then you come back a year later and they don't know who you are. But of course, the average pet dog will know who you are and will remember that, right? And so its behavior with you on that second occasion will, in some sense, be coherent with the behavior that the interaction that you had on in the first interaction. And there are stories of chimpanzees too, over the course of weeks and months, building up a cache of rocks so that when that person reappears, they can throw them at them, right? Oh. So there's sort of long-term planning here, right? That's a kind of global coherence to their behavior. But could a chimpanzee make a 5-year plan? Probably not. A human can. So I see this as a matter of scale, but I think that the LLMs that we have don't have that. They even lose the thread within a particular interaction that you have with them over the course of minutes, particularly if you know how to push them in certain directions. So they lose the thread in ways that that they don't notice, and they also say things that appear to convey understanding of the structural properties of some problem. But then when you actually ask them to solve the problem, they don't apply the very principles that they espoused, just a page earlier. So I've done a lot of mucking around with these things with respect to kind of some fairly basic mathematical problems. And early on, you could sort of get them to tell you how to calculate, let's say, the modulo 3 value of a hexadecimal number. This is one of my favorite examples. And then you'd say, okay, or it would even volunteer. And so when I do this, I start with this hex number and I get this, this ends up being mod 2. It was getting it wrong at every stage of the calculation, even though it had correctly described what the calculation should be, right? So it clearly wasn't using this structural knowledge, which just means its ability to state the correct structure of the problem. It clearly wasn't using it to actually compute the value. And over the years, I've played, this is one of my sort of go-to tests with each next iteration. Where are they with this? Over years, they've sort of gotten better at giving the right answer, partly because they've bolted in an actual calculator, right? So it's not the LLM itself. Yeah. It's just like, oh, this is an arithmetic problem. Let me send it to the calculator and get the answer back from there. Partly because their training set now includes people like me giving it these harder problems, so they can sort of use the harder problems to do this. But then there's still a limit. So if I give you, 1,000-digit hexadecimal number and say calculate the modulo 3 value of that, your calculator will overflow. You can't do it on the calculator. You could sit down with a piece of pencil and paper, a piece of paper and a pencil, and work it out. It would be tedious and it would take you a long while to do it. There are certain tricks to make it easier. But there's sort of, this is an old point from Chomsky. There's sort of no principle bound to the length of the problem that you can do because you understand the structure of the problem and you can use that structure to guide this sort of tedious process that you do. The LLM can state the structure of the problem. It can even now decide when to hand off the calculation to some other gadget, but it can't do anything that is beyond the capacity of that calculator, right? Because it really doesn't understand the structure of the problem.
Right, because if the problem's too big for it to fit in its context window, then it's just it may be locally coherent in a certain area of the problem, but can't see the forest through the trees. Yeah,
Right.
wow, that's pretty profound actually, to think about it that way. Do you think there'll be much progress in this global coherence issue without bolting on cheats or anything like that, right?
Yeah, right. Good. Yeah. So I think that there will be progress. I think that the progress, as you mentioned, is initially going to be because we bolt on these systems that are nothing like what we have accessible to us internally. Of course, I have a calculator on my laptop or on my phone that I can pull up when I need to do some piece of arithmetic that I don't want to do on pencil and paper. So in some sense, I will rely on those gadgets, and it's okay to allow these things to rely on those sorts of gadgets too. But I think there's a bigger problem, which is the way in which, or a bigger issue, which is the way in which all kinds of different components of our cognitive architecture, for want of a better term, interact with each other in ways that produce synergistic effects, capacities that sort of go beyond what you'd predict from any one piece alone. So you can push LLMs to have bigger and bigger buffers, but you're always going to run up against the limit of that. But then there are ways in which I think of taking the particular experience of the system and storing it so that it can be quickly retrieved and fed back into the
Right,
buffer.
chunking,
Right.
or compressing and chunking relevant things together so that
In
it's
real time,
consumable
which
within
these
a
things,
small
right,
context
good.
window.
Yeah, that's right. These things have none of that kind of architectural structure, right? They in the course of a conversation with them, of course, their response is shaped by what you've interacted with them over before, and so there's a kind of change of behavior through time, but it's not getting reflected in any weight changes. You've got to go through this laborious, expensive, time-consuming retraining of the base model to get any of that back in there. We're not like that at all, right? That is, you convince me of some fact right now that maybe I didn't even believe, or I believe the opposite of, and that not only immediately affects what I do, but continues in other conversations and other contexts to do that, and might last a lifetime as well. So that's because of, I think, a far more complicated set of relationships between what's generating the language and what's keeping track of the organism's interests and needs and so on. And this comes back to the question about animal cognition too, right? So animals obviously can't do the kind of language that we do. But I think that just part of the demand of being something that learns where to get food and when to get food and all the rest of it demands a kind of set of interacting systems that are not going to be reasonably modeled in a kind of a monolithic transformer.
Look, I'm glad that you can update your beliefs so quickly. I think a lot of people struggle with that. Like if they're convinced of something, it takes a while for them to actually process that and to take it on board. I think it's a really good quality. It's epistemic humility to be able to be sort of quickly convinced of something. Yeah,
Yeah, I mean, maybe it also depends a lot on how fundamental that is to a bunch of other things you believe. So, I could very quickly tell you something about myself that you didn't know,
yeah,
and you might forget it, an hour later, or you might find that you still remember it 30 years later. So, for instance, when I was 8 years old, my family moved from the UK to Trinidad, right, in the Caribbean. You now have this fact, right? Whether this sticks with you in 30 years, I don't know, right? Maybe we'll have a beer somewhere and you'll go, I remember you telling me, and look, I still remember that, right? There's all kinds
yeah,
of ways in which that could get instantly taken up. But that particular belief or that particular bit of knowledge doesn't conflict with anything
yeah,
else that you knew. It doesn't require a major sort of change. Whereas if you sort of become convinced, let's take some politically, you become convinced, you used to be convinced that, let's say homosexuality was, a sin. Now you sort of become convinced that, well, we're all God's creatures, and so you're sort of haven't given up on your theism, but you sort of say, wait a second, right? This means that all kinds of things that I thought were sins might actually be just part of the divine plan, right? That's going to require a much bigger set of processing. It might take you longer to assimilate that into your own belief set, and also much longer to change what are, to this point, perhaps kind of habitual responses to signs of being gay and so on, right? And those kinds of habits are built up over many years, and they can be hard to overcome, right? Um, you know, if you grow up in a racist environment, it can be very hard to overcome your sort of first responses, right? It takes a real effort to go, oh, wait a second, I'm having that response. No, that's just wrong, right? So yeah, I think that the dynamics of this are complicated, and it's going to depend a lot on the centrality of the belief to some other thing that you have. But this is another important point, I think, about LLMs, right? They're trained on a bunch of data, like words, in a way that every sentence in that training set has equal value, as it were, with respect to how they should update the weights, right? Whereas you and I, if you read something or hear something, don't have to take that into your
yeah, yeah.
you could reject the data in a way that an LLM can't,
Okay.
right? And so we have filters on what we allow in to reshape this sort of set of beliefs that we take to be sort of core to our own self-understanding. LLMs have none of that, right? They, everything is equal, and this is why then you have to do all this human feedback reinforcement learning to kind of suppress the stuff that humans think is bad, because to the LLM it's all the same. It's got some data from Reddit where people say Hitler was the greatest person ever, right? And that's of equal value to the other Reddit channel where they're saying Hitler was the worst person ever, right? And somehow or other, it has to, it'll, depending on the other words that you put around it when you create a prompt, it's going to come up with something that, reflects the first Reddit group's the likelihoods, or the second Reddit group's likelihoods. And you have to then bolt on top of it this sort of reinforcement learning module, which suppresses, right, the core models, complete inability to distinguish between those two. But of course, you can only, this is part of that suppression is it's very haphazard, right? If you haven't given the human reinforcers, the human evaluators, the right set of examples or a complete enough set of examples to evaluate, the machine is still going to be producing stuff from its original core model that have never been subject to this kind of reinforcement learning.
Yeah, it's fascinating. You may be aware that there's been studies on political leanings within large language models. Dan Hendricks and others have sort of called these cohesive values. So they cohere somewhere along the political spectrum. From what I understand, they cohere left. Actually, I'm using the word cohere prematurely. That could just be based on their training data. Arguably, it could also be based on a lot of other things, whether there's a particular point within the political spectrum which coheres with other facts about the world and a lot of the other knowledge, whether there's some form of coherence underneath the hood going on to explain why it's seemingly having a sort of a political preference or political position or a political value. So yeah, so would you think that it's not doing any coherence under the hood, and it's just based on the weight of training data that it's given, or is there another bolt-on module over and above what's going on that's sort of helping cohere what's going on inside the LLM?
Yeah, I tend to think it's the former. I think it's the bias, meaning that term just in a neutral way, right? The lean of the input that's driving the lean of the output here. I could be wrong about that, but I just don't see a lot of evidence for these systems doing anything to, as it were, filter out some things as being less plausible than others. I think it just doesn't have the means to do that kind of evaluation.
Well, let's talk about value loading, talking about on the subject of value. And speaking to Nick Bostrom, Anders Sandberg and others, back in the day, the thinking was we'd get this sort of AI that was agentic, it would be really good at math, it would have a really alien mind. But what we've ended up with is something that can consume huge swathes of text, arguably making the value loading problem easier. If you loaded the right text, if it's fed the right data, then it will be biased towards the right thing, right? If you know what's actually valuable, and especially if you're a moral realist, you give it the right moral text, then it will converge on values that are somewhat value, quote unquote. So yeah. How do you see all this? What are your views and where we're at with value loading in AI? And you say that AI doesn't understand, but where do you think? Do you think in order for AI to have values, it needs to understand them in the same way as a human does?
Yeah. So I think it's a great question, and I think that there's a lot that that nobody understands about exactly how these things produce the particular responses that they do. Of course, in completely general terms, we understand the training algorithm and the weight changing and all the rest of it. What we don't understand is interactions that occur within the system. And so I think even if you load the system up with sort of only good ethical views and train only on, you cut out all of the Reddit groups that are praising Hitler and only include the ones that are pointing out all the ways in which he was an awful person. I think that you would still have worries about whether this is sufficient to make sure that this thing would never spout unethical views or make unethical claims or make bad decisions. And partly that point is driven by something that came out. You might have seen this just within the last week or so, a couple of weeks, or I forget the exact date. But basically what they did was they took a fully trained up LLM, and then they did some further fine tuning that made it more likely to produce bad programming answers for programming.
Yeah. Alignment
right?
bleed, right? Was that
alignment bleed, right? So you know exactly what I'm talking about here, right? So it could be that you carefully curated your ethical sources, right, for the training of this, but then something that's not ethical at all, right, where there's kind of the same sort of, in this case, what's surprising about it is not even the same kinds of tokens, right, that are involved. But there's some other part of the training set where that's sharing part of the weight space of this first task, right, is still allowing the possibility for the machine to generate what should be considered low probability responses if you just looked at this corner of the training data, right? But turns out to be higher probability when you look at the training data as a whole. So I don't think it's a full solution to the problem just to say, oh yeah, we should just more carefully curate the ethical part of the training set. I also think that the human cost to doing that curation is prohibitive from the point of view of these companies, right? It's expensive enough for them to do the kind of post hoc reinforcement learning from human feedback. It will be 10 times or in orders of magnitude more prohibitive to actually, for every piece of text that they feed into the training.
Yeah, to weight and label it, right?
Yeah, to decide whether or not this is something that the core model should be allowed to see. Yeah, that's just not going to happen. And of course, it doesn't happen. We try to train our kids in certain ways, but we know that out there they're encountering all kinds of behaviors that we don't want them to model, right? So of course we engage in a kind of reinforcement learning with them as well. But we also, at a certain point, trust them to have decided that, oh, this is the kind of thing I should not model. I am going to, block my ears, or, whenever I find myself, wanting to say that thing or think, use that word, exercise my own control and suppress it, right? And we don't have an architecture for that in the current transformer models, it seems.
Yeah, it seems like I've always thought that getting AI to actually understand stuff is really, really important. Becoming even more important to me as we have this conversation.
Right.
So,
That said, we are also. I've taught in a number of different places and encountered people who speak in all kinds of different ways,
mm,
um, and find exposed to lots of undergraduate student essays where instead of for example, instead of for all intents and purposes, they'll write for all intensive purposes. And then you find yourself like, after having read dozens of this thing dozens of times, you start typing for all intents and you find you've typed intensive, right? There's sort of a ballistic nature to the output, which has been driven by the input. But you also have this self-corrective thing, right? You know what it should be and you can go back and fix it. Right now, the closest we've got to that with the LLMs is they'll take their own output and then run it through an evaluative process and generate some more output. But there isn't this sort of ability to sort of decide, oh, that was wrong, I'll fix it. You don't see the sort of backtracking. When the output comes, it's all one directional. There's never, backspace never never occurs, right? There's not the real time on the online censoring of the output that we do with ourselves, both verbally and when writing.
yeah, yeah. I mean, when we're talking about automated warfare and all that sort of stuff, yeah, you write about that in the book quite a lot. In the AI alignment community, I know there's a lot of focus on control and AI safety. And to my sensitivities, there's not as much discussion and attention on actual AI ethics. So, I mean, would you rather end up in a world where AI that didn't understand ethics, but was under human control? Or would you prefer to be in a world where advanced AI, we're talking about superintelligence in both scenarios here, and where advanced AGI did understand ethics but wasn't under human control? If you had to choose one, which would you prefer?
If I had to choose one, I think I would choose the first. But that answer is partly determined by by considerations that come out of this distinction I gave you earlier between moral machines, right, what the machine can do, and AI ethics, which is the larger kind of context, the socio-technical context in which machines and humans are all part of the system. And I think that one thing to say is that even if you had this advanced AI that would, make better decisions in the battlefield, I think having that around in the socio-technical system makes, let's say, starting a war more likely. It's easier. It lowers the barrier for going to war, right? That would be an unintended effect of having more ethical military robots. And that's a point that's often been made about military robots and remote warfare and drones many times. But I think it's further compounded if you now think, and these things are going to make better decisions than a human would in that situation, because now we can just trust them to go there. And yes, there'll still be some collateral damage, but that's the best we can do. And there's a tendency in that situation to think, well, I'm not really responsible for those deaths as well. So this gets into all of the big AI ethics kinds of questions about how responsibility gets diffused, there's a diffusion of moral responsibility when you have machines with this kind of capability. Whereas if there are people kind of involved in it at every step, then that diffusion is less likely.
Yeah, there's the issue of care. An AI could understand everything there is to know about ethics to a higher degree than every human in the world, but it may not care, right? It could have a global understanding of science. It could have a global understanding of physics, ethics, ontology, meta-ethics. It could understand everything, right? But it wouldn't necessarily care, right? What's the motivation for the AI actually to care about ethics?
Yeah. And well, the same question gets asked and has been long asked by ethicists about why we should care about being good. And there's a sort of biological naturalist answer that just says, well, we just do, because it turns out that humans that did care about these things, formed societies that were extremely successful. So there's sort of an ultimate evolutionary answer to that kind of question, perhaps, that doesn't nevertheless provide a kind of immediate reason why one should care in this particular moment. It's just a fact that we do. But it's certainly the case that without caring, without having some kind of investment in the outcome, it's hard to see why humans would be motivated to do certain things. Do machines need that? So, as a matter of fact, I'm working on a paper right now on whether robots need emotions.
Right, yes, yeah. I've noticed you've given talks, and you did give weight to some of that in the book.
That's right, yeah. So, it's a natural outgrowth of a couple of thoughts that originate in the book, which is that, one, the emotions tell us something important about the situation. It's part of that ethical sensitivity, right? You find something, right, bad in a certain way, in an emotional way, that's information to use, right? Your facial expression tells me whether or not I'm causing you harm, right? And so this is that's all part of just ethical sensitivity. So robots would at least need the ability to detect emotions, but do they need it themselves? So there's also then, the kind of sentimental moral epistemology, the idea that, when I do feel offended by something, right, that's also, it's not just that I detected that you're offended, I feel offended. That's a kind of source of moral knowledge. It's not perfect moral knowledge, just like perception isn't either, right? You can think you see something that's not there. You can feel something that makes you think something is morally bad about the situation and be wrong about that. But nevertheless, it turns out to be, a reliable enough, useful guide to actually be something that should be factored into the capacities of, the moral capacities of humans. And then the question is, do robots need that? I also think that the emotions will also have further cognitive systemic effects on us. So when you're fearful or when you're angry or when you're happy or contented, you process the world differently. You process the world, you focus on different things. Your attention is drawn to things differently. Your planning changes, right? There's all kinds of knock-on effects of these emotions that are adaptive and that have an ethical dimension to them. And in many cases, in all cases, have to be traced to some sort of physiological change, right, within the person who's having these responses. And lacking that, it's you'd have to get the whatever the benefits are of fear. Well, I think there are benefits, right? That you'd have to at least mimic that structure internally in a machine for it to get those same benefits. So I think there's a general argument that emotions matter not just as sources of information, but as modulators of the system itself, and that caring involves these kinds of emotional responses, and that being adaptive in a social group, right, and respecting the needs of others and so on, morality being about, in some way, putting aside your own interests and taking care of the interests of others and caring about taking care of the interests of others. All of that strikes me as our best current model for what it is to be a moral agent in the world. And maybe you could accomplish something similar to it without any of that, but it seems like a harder hill to climb to sort of figure out how to do all of that completely without paying any attention to what emotions are and how they drive behavior and change perception and affect memory and all the other things that they do.
Yeah, I'm not sure if I'm the originator of this idea, but it's sort of somewhat related in as much as hedonic valence, or the raw fields of qualia, access to pleasure, pain threshold, and that is, imagine the knowledge argument. You're Mary in the room and you've never actually experienced color before, but you're an expert in color. When you walk outside the room, outside of the grayscale room, suddenly the knowledge argument asks, do you learn anything new? I think it's if you apply that to qualia, if you have a machine intelligence that understands enough about qualia, understands how it works, its operational underpinnings, have read all the scientific papers. Let's say we're in the future and it actually understands all this, not today's LLMs. Would it want to engineer in itself the ability to feel qualia in order to have access to raw experience and give weight to moral arguments? If there was a doorway for it to walk outside its qualia-less room, would it walk out? And if it did so, would it learn something about ethics, arguably how to care, or get access to the phenomenology which would give weight to ethical arguments?
So yeah, it's an interesting thought experiment, but like all such thought experiments, I find myself thinking there's so much that's unspecified about this that I'm not quite sure how to respond.
It's certainly not an engineering plan.
So yeah, so if you've got a system which lacks these qualitative experiences, and now it sees a route to give itself those, why would it care to do so if it lacks the qualitative experiences, right? What would motivate it?
One
to
argument
do
is,
that?
well, it sees all these other people caring about this, and it wants to know, well, why?
Yeah.
What's so motivating about all this? Shall I dip my
Yeah.
little toe in and see what the water's like, right?
Yeah. But you
Also
also
because
have
we ask it to.
well, right. So you could just say do it. Um, but there's perhaps an interesting analogy here to people in the deaf community who go, look, I understand why all you hearing people value hearing, but actually, I've got a very nice life here and a nice culture that I belong to, and I just don't want my hearing to be fixed, and
Mm,
this is the form of life that I have, and it's the form of life that I like. Now, in this case, we're dealing with uh, beings that do care already. They care about their current identity, their current form of life, the current social relations, and all the rest of it. And although they understand why somebody who has this thing they don't have might think that it would be better to have that thing.
yeah,
They're like, I'm okay with how things are, right? Um,
sure.
so so
Look,
other
yeah,
than
yeah.
ordering the robot to do this thing, I think, what's the rational motivation for doing that? Maybe some would do it and some wouldn't. Um, you know, but it's unclear to me exactly what would motivate it.
If I take off my glasses, I find it really difficult to see. So there's instrumental reasons for me putting on these glasses.
Hmm.
There's instrumental reasons why some deaf people put on, opt for
Yeah.
cochlear implants.
Hmm.
There may be instrumental reasons for AI to install the qualia module, and that may be to see if there's anything to understand about human cognition or human psychology, or any life form psychology that involves qualia.
Yeah.
Um, you know,
Yeah, I'm sort of
so
glad that you started with Mary, not zombies, because I think that if you start with Charm Zombies and you think of qualia in those terms, then there
ah
are no instrumental reasons for having qualia, because by hypothesis, the zombie can do everything that the non-zombie can do.
yeah, I just don't understand how a exactly physically equivalent zombie would be exactly the same in every other way to a normal
Mhm.
human being and not experience qualia. Because I think qualia is a product of our physics, basically, our biology,
That
which rests on physics, right?
right,
So I just
right,
don't agree with the argument.
right,
From a
right.
physicalist point of view, I just don't see how it's
Yeah.
possible. But
So
if I take the idea that a zombie is missing something, it's missing the architecture that allows for qualia. If it had the opportunity to sort of decide whether it wanted to try that architecture on like a coat, it might decide to. I'm not completely
mhm,
convinced that it would or wouldn't.
right, right. Yeah. So if my current or my what I was saying previously about emotions and the kind of widespread, the way in which they're all entangled with all sorts of things, like how you perceive the world, how you attend to things in your environment, what kinds of decisions you make, and so on. Um, uh, uh, I think there's a real question here about how much of that you can get um, without being in the position where you say is, okay, now you've got a system which just has qualia because it has this set of physical or biological or whatever structures that enable all this other stuff to happen, um, and how much we should think of of the feeling of the emotion as some further bolt-on that is not itself doing anything with respect to all of these other functional aspects of emotions that you might be able to replicate without that bolt-on. So again, I said that I always find these thought experiments rather underspecified. But if we're thinking of qualia as just a kind of a functionless bolt-on, I'm not sure why anybody should choose it. Right? Just sounds like a
Well, that's
world of
just
pain to
yeah,
me.
that's a limitation of my explanatory capabilities there, I'd say. But yeah, I mean, in terms of just trying to sort of compress the thought experiment into sort of manageable form, I chose the words bolt-on because that was first came to mind, right? Um, yeah, I don't know whether it would just be a module that you just bolt on, whether it's something about tweaking the underlying sort of substrate. Yeah, I don't know.
Yeah,
I'd have to think
yeah.
about it more carefully.
I mean, if it turned out that you could knock out one gene in such a way that people talked as if they had experiences, but actually weren't having them, it's really hard to imagine exactly what that gene would be doing, right,
Right.
to the system.
Yeah. Well, we have psychopaths who, I think in your book you say that they don't experience some emotions, but they must experience pain and pleasure, right? But
Right.
there's something missing. We don't fully understand what's missing because we don't have a complete sort of view under the hood, operational understanding of how the human brain and nervous system works, right?
Right.
Um,
Right. And we
yeah,
don't really even know whether it's one syndrome or one
yeah,
condition, right? It could be different for others. But what seems to be the case for many of these individuals is that they get pleasure themselves out of causing pain to others. They recognize that the other feels pain, but that pain itself has no resonance in them. So there's a kind of empathic deficit of a sort.
hmm. Yeah. It'd be really good to have like operational understandings of how all this is working instead of more operational understandings, and instead of just only relying on behavioralist. That's for certain.
Mm-hmm.
So yeah, you go into the importance of autonomy in the book, and I like the crispness of Luciano Floridi and J.W. Sanders' key features like interactivity, autonomy, and adaptability, and all that to describe how it all, to model how it works. So, just in like, would you just want to describe why autonomy is important for artificial moral agents?
Well, I think we thought it was important because it's the dimension which establishes the need for AMAs. So it's the ability of these systems to operate and uh, choose among options without human oversight, immediate human oversight, human in the loop or even on the loop. Um, uh, that sort of it echoes what Rosalind Picard in her affective computing book said: "Is the more a machine has freedom, the more it will need moral standards." Um, yeah, the openness of the system, its ability to operate in more and more open situations without the kind of oversight of humans is what I think makes it the case that you need this ethical sensitivity and some ability to to reason about it. Um, where reasoning could be understood purely formally, or it could be we could make it a thick sense of reasoning where we're concerned about genuine understanding and all the rest of it. So that's part of the progression from what we call functional morality to full moral agency. Um, so yeah, autonomy is one of those things that just is a prerequisite for the need. If you have a system with no autonomy, like the factory robot that's bolted to the floor and simply, repetitively, bolts a door to a car or something like this, right? It has zero autonomy.
Mm.
Um, um, there's no need for it to be a moral agent. It's just the notion of moral agency doesn't even get off the ground for such a system. Now, there's another tradition in ethics, this is due to Kant, in which um, there's a thicker notion of autonomy, but in particular, the notion of autonomy is not just self determination, but also something like the freedom to do bad things. And you need morality because, in Kant's view, we're always tempted to be sort of selfish and use others for our own purposes and all the rest of it. And the moral person is the one who overcomes, right, that kind of tendency, and that requires a kind of thick notion of autonomy that verges on free will, to sort of overcome these external forces or even internal forces that might be driving you towards doing the wrong thing. But we were not thinking of autonomy in that sort of already ethically thick sense. It was really just autonomy in the freedom from oversight sense. But if you do take that ethically thick sense, then it's not only a kind of a condition for the need for moral capabilities, it's actually a condition for being a moral agent at all, right? Is that you are free to behave badly.
Yeah, I guess it's implied in the term agent. Yeah.
You're right.
So, I really like the diagram you've got with, on autonomy and ethical sensitivity as axes. And today's robots have both, well, when you wrote it, low autonomy and low ethical sensitivity. So yeah, or functional morality. But there's these layers where you've got operational morality, where, this is sort of a similar, I guess, to hard-coded morality. And then functional morality, and then up the very top right hand, you got the full agency spectrum. And ideally, we get to the full agency spectrum before we get to superintelligence, I guess.
Right.
But look, where are we at? And do you use this dimensions of AMA development diagram anymore? Because I thought it was nice, just a nice way to visualize it all.
Well, thanks. Yeah. I mean, I use it as a teaching tool. Do I? I think it was
Yeah.
only ever at best a sort of a way of crudely mapping a landscape that
Yeah.
helped people understand where developments in one direction weren't necessarily giving you everything that you might want to build into these systems. So we had some examples of more autonomy. So an autopilot could, in principle, run an entire flight from takeoff to landing. Most pilots don't use it that way. They use it somewhere mid-flight to sort of, when there's less chance of things going wrong that the machine can't handle. But there's certainly a capacity there for automated flight, and now, of course, we have the
Drones.
capacity for driverless cars, right? Although, again, I think that's within certain tight bounds. So San Francisco, for example, where they've got a bunch of driverless taxis, works well because the streets of San Francisco are extremely well mapped. You could not take that car and simply plunk it in some other city, even with all of the mapping stuff, and expect it to do as well, because there's a whole bunch of very site-specific information that makes it work well, and they're strictly geofenced. So those taxis cannot go, down to Palo Alto, for instance, right? They're within this area that's very, very tightly mapped. So they have an appearance of a kind of autonomy, but it's not. It's not, in fact, full-blown human. You could get a human Uber driver and say, in San Francisco, and say, take me to Dallas, and that person would say, that's going to cost you, $5,000, and you say, fine, and off you set, and you expect the driver to be able to adapt to the changing conditions as you go along, guided by the GPS navigation. I would not trust one of these self-driving taxis that's sort of highly tuned to the particular environment in San Francisco to do that, and they won't, in fact, let it do that.
Right. Okay. So that's something I didn't know. Yeah, that's interesting. So I guess that's still somewhat operational morality built in a sense, or operational sort of autonomy. Yeah.
That's right. I mean, it's functional. Right. That's right. So, and in fact, they have a bunch of people overseeing the cars. So there's still a lot of human oversight in those systems,
Right.
too. Sometimes the car gets kind of in a situation where there are vehicles on all sides, and the software on board can't find a solution for getting out of that, and then it gets booted up to some supervisor who was merely on the loop, so that they become in the loop,
Yeah.
and actually remotely take over the control of the car. All of this is unseen by the passenger, right? The passenger
Yes.
doesn't know that this is happening. But I read some statistics a couple of months ago that said that this is happening sort of every 3 minutes across the whole fleet, or something like this. It's a continual and ongoing human supervision issue. Particularly, it turns out, when emergency vehicles are around. So, fire trucks or fire engines and ambulances and police cars tend to position themselves in roadways that are, completely non-standard from the point of view of moving traffic, and of course driven by the particulars of the incident that they're dealing with, right?
Mm-hmm.
And so these are, out of the box of the normal set of conditions that these self-driving
special
vehicles.
circumstances.
That's right. That's right.
As E&M
Yes.
banks might call it. Right?
That's where most of the accidents have occurred as well, right? So, Teslas running into the back of fire trucks is not a unique phenomenon, I believe.
Okay, that's interesting. Well, it does seem to be a push towards getting some form of functional automation going. Like, for instance, if you've got drones, they're flying in an airspace where there's unreliable signal to be able to phone home, so that you can't just get somebody to drop from on the loop to in the loop at a moment's notice. Then you need that sort of, because it costs a lot of money, these drones, right? People don't want to just throw them into situations where there's unreliable.
That's right.
Unreliability.
Right.
So yeah.
Yeah, Rodney
I don't
Brooks
know how.
once made a really good point about this. So he pointed out that the real ethical issues for robots is not military robots, because they cost so much, and there's all kinds of problems if they fall into enemy hands and so on. And the military has a huge amount of at stake in making sure that they get everything back, and so there will be human oversight of that. Whereas, your home robot that you leave to clean the house for the day, and you go out, right? If you want it to have more, if it's not just Roomba, which is sort of dumbly running around getting tangled up with the wires and very limited ability to extricate itself, right? If you want something that actually understands whether or not it can pull that socket out of the wall, because that socket maybe is attached to some piece of equipment that is actually critical for somebody's health or well-being, right? That's where you're not going to be able to afford, as the homeowner, to have some person who's constantly monitoring what this thing is doing, and that's where he thinks the ethical problems really are located.
Yeah. So you talk about bottom-up and top-down approaches in your book. Do you want to describe what bottom-up and top-down approaches are, and why there needs to be a combination of them?
Yeah, good. So, right, this is something that actually goes all the way back to the 2000 paper, where we were thinking about how does ethical theory play a role in the design of artificial moral agents. And one obvious idea is, well, pick your favorite ethical theory and turn it into an algorithm, and have the machine follow that algorithm. This works, initially plausibly for something like utilitarianism, which is just evaluate the likely increase in pleasure of each of your, or decrease in pleasure overall of each of your actions, and choose the one that maximizes, right? This is a standard utilitarian kind of story. Practically, you realize that first, this is intractable, because the ramifications of an action extend indefinitely in time, and so you have to do something like estimate what's likely to happen as a consequence of your action, and that just sort of blows up really fast when you start thinking about all of the possible interactions. or any other top-down theory we argued had the same sort of problem. So top-down then is you're starting with some predefined theory that gives you the grounds for sort of an algorithm that would then govern the machine's behavior. So then the alternative way of thinking about it is, well, we learn from experience and we learn from mistakes and we learn from other people's mistakes. And so you do something and you get feedback that in that situation was a good, had a good outcome, or it didn't have a good outcome. And so you retrain yourself, you kind of learn from that, and you watch what other people do and sort of figure out what's considered morally acceptable within your community. And that has certain advantages, and it has advantages that allow you to take advantage of both what other people do and also maybe pay attention to features of the situation that aren't explicitly mentioned in any of your top-down theories. So you just learn that when something like this is going on in the environment, this is the thing that will be judged morally acceptable. You don't have to sort of compute, well, how much pleasure or pain is caused by this. You just have this sort of much quicker judgment. Oh, this is the kind of thing that in the situation produces that judgment. Now, I've been carefully phrasing in terms of judged acceptable because, of course, you could be living in a society where you decide that what people are judging as morally acceptable, let's say slavery to pick an example, in fact isn't, right? And so why do you decide that? It's not because people around you are not tolerating slavery. In fact, they're fully participating in it. Of course, some of the people are railing against it, right? So you've got conflicting inputs from the bottom up in terms of the data you have about what is acceptable or not acceptable. And you have to actually apply some kind of principled reasoning to help you sort that out. Now, I don't want to sound right. Earlier I said I lean towards a kind of particularist view, so, but not the kind of particularism that rejects the utility of theory. So I think you can look at, let's stick with the example of slavery, you can look at that through the lens of utilitarianism and ask yourself, well, would it be better if there weren't slaves? Some people wouldn't be making as much money and living in as nice houses, but lots of other people would be, in other situations that would be better for them. And so you can sort of apply a utilitarian calculation to that. But you can also take a Kantian perspective on it and go, well, look, the principle of slavery itself fails to respect the autonomy of the rational individual who is the slave, and so it's wrong on that count, and we can sort of use that as a guide to what's right and wrong, separately from how people are actually responding to it, right? What you would learn just by observing what certain people are doing. So that sort of argues for the need for a hybrid system between bottom up and top down, right? So the details come from the bottom up in a certain sense. Some kind of principles, but not overarching or rigid principles, because some things, if it's killing one person to save two versus killing one person to save a million, right? The one against a million is a clear choice. The one against two, not so clear, right? There's sort of the strict utilitarian calculation doesn't really help you out in all cases. So I think, but the Kantian prohibition on using one person to the benefit of others would rule out doing either of those things, right? So you have to kind of triage the principles and think about judgments that would be made about these things, and it's just a back and forth between theory and experience. I think that correctly describes what's necessary to be an effective moral agent. If you're rigidly utilitarian, you're not going to be effective. If you're rigidly Kantian, you're not going to be effective. And you're not even going to be computationally tractable in either case. So if you think about machines, you can't do that.
The more capable machines get, does this mean the more weight they can put in top-down approaches, or the more weight they should be putting in bottom-up approaches? I mean, does the meeting point change when machines get more capable, or does it depend on how they get more capable?
Yeah, I mean, the obvious way out is the one you gave me. It depends on how they get more capable. But I also think that there's no formula for how much to weight things. So maybe this comes back to the particularism, right? There's attempting to state the principles in full detail is an impossible task, and it's rather like this. You might think, oh, I need to take a bus trip from Canberra to Perth. Now, there may be no bus that goes direct, so you've got to change somewhere. Maybe you've got to change in multiple places. So you've got to look at a bunch of timetables and figure out, what's the best way to get from here to there. And in a sense, the timetable is your theory of the buses, right? And sort of top-down reasoning, you can do this. But then you think, but buses get delayed, so maybe that 20-minute changeover is not adequate, right? Maybe I should choose the route that has a 1-hour changeover. Or maybe that's not enough because I know something about the weather forecast that's going to make me think on this particular day that's not going to be enough, right? And all of these particular details can affect the way in which you use that timetable. Even when you take all of those variables into account, you're presumably not thinking about the possibility that some comet will come and land on the bus terminal while you're en route, right, to it. There are things outside of this that could affect, what you do. But by experience, you kind of don't have to worry about comets falling on buses. You do have to worry about weather-caused delays, right? But the bus schedule itself doesn't have to keep reminding you of all of these things, these myriad things, some of which you may be able to think of easily, others which you may not be able to think of easily, some of which your weighting of those will depend on, how many times you've missed a bus because of the weather and your own experience or people who've done it, right? So it's always going to be this interplay, and you can't say, well, the more the machine knows, the more it can rely on the timetable, or the more the machine knows it should rely on, all of the data about bus trips that people have taken, when sometimes they've missed the connection and sometimes they haven't, because for some people, missing a connection and having to wait for the next bus could be a very big deal because you've missed the wedding that you were going to, and for other people it could be not such a big deal because you were going there for 3 weeks anyway, and whether you get there today or tomorrow is sort of neither here nor there. And I mean, obviously you'd prefer to get there today, but you can afford to take the risk of getting there tomorrow if something goes wrong. None of that seems to me, to be solvable just by having more capacity.
Mm-hmm. Okay, so if you had the ear of some of the major players in these big AI companies today, what would you say to try and, nudge them in a direction that you think is better in terms of achieving AI outcomes that are more desirable for the aggregate of humanity, and arguably the welfare of all sentient life on the planet?
Yeah, so here again, I want to rely on the distinction I had before between what do you build into the engineered system itself, and what do you build into the socio-technical system in which you embed it. And I think my emphasis has gone over the last 25 years, from sort of just focusing on the artifact, the AI system itself, to thinking about the larger system in which it's embedded. And part of what we did with a project that I called the Machine Wisdom Project, or Wisdom in the Machine Age Project, is to say, look, there are multiple stages in coming up with an idea for some AI system. And here we're just talking about, dedicated AI, not AGI. But I think the same sorts of things apply to AGI. But coming up with an AI system and then actually having it used at the end. So there's some sort of product conception, there's some sort of development and programming, there's some kind of testing that feeds back into the development, and there's some sort of marketing to get it out in the hands of users, and then there's the users themselves. And I think at each of these different stages, you need to figure out who needs to be in the room, right? Which humans, what kinds of expertise are relevant to helping you avoid some of the pitfalls that have not just been made once, but actually have been made repeatedly by people in the tech industry who've sort of ignored their own history in various ways, right? So do you need a philosopher in the room? Maybe somewhere not. Do you need... it's going to depend on what you're developing. So if you're developing some medical triage system that's going to be AI-driven, maybe you need representatives of patient communities, not just people with medical expertise and people with computing expertise, right? Because decisions get made at that very early stage about which data sets to train on and how this thing is going to operate, that people who've had experience with the medical system as patients might go, that's going to really not work well for us, right? And I think those kinds of inputs often get ignored at that stage because, for a couple of reasons. First, when non-experts or people, to put it better, people who have expertise in being the patients in the medical system, but not expertise in being doctors or expertise in being programmers, often get dismissed because of their lack of expertise in the technical aspects of this. So you've got to really carefully think about how you get that conversation going in a way that there's proper respect for and understanding of the concerns that somebody who's not a programmer or who's not a physician might have about what the goal of the system is and how it's going to work, right? So one thing to say to people, in the tech industry is, don't just be in your own echo chamber of wouldn't this be great? And by the way, if we break something, we can fix it later. Because often by the time you get to the point of realizing you've broken something, you've gone down a whole development path that is really difficult, if not impossible, to unroll. You would have had to have done something really different at the beginning. So to jump to entirely the other end, here's, let's take Tesla saying, well, we call this full self-driving mode, but it's not really autonomy at level 5 of whatever the National Highway Transportation Safety Board's categorization scheme is in the U.S. So, it's really only at level 2, which means that you should have your hands on the wheel at all times, right? And do people take that seriously? Well, some owners of Teslas do. Some won't use the full self-driving at all. I count myself in that category. And some, go, well, this seems to be working well enough. I can, read a book while this is going along. And if we think about how little is done to actually get end users to understand the ways in which these things will fail, not just can fail, but will fail in certain circumstances, and under which circumstances they will fail, you might think, okay, the industry has an obligation here to provide the kind of training to end users which gets them to understand the limits of the system as well as its capabilities. Because you can make mistakes in both directions, right? You can take control when you don't need to, and you can fail to take control when you should have taken control. How do we do that? Well, if you think about what pilots have to do for airplanes, they have to do all of this simulator training where they're put through all kinds of failure modes, right, and learn how to deal with those. So you might say, okay, well, we should have a similar situation. Every Tesla driver who wants to use this mode of so-called full self-driving should first go through simulator training and maybe repeated simulator training, just like pilots do, to make sure that they're capable of dealing with the situations under which this thing, won't do the right thing. Of course, that's the last thing Tesla wants to have any of its customers do. So now you get a question of, is this the kind of thing that, if that's in fact what's necessary, right, to have an ethical product out there, the government has to get involved and make it a requirement, and then you're in a whole world of politics, of course, right, which I'm not optimistic about ever imposing that requirement on Tesla drivers for all sorts of obvious reasons. That said, though, if we go back a little bit earlier to the marketing phase, right, this is being sold as, with the label full self-driving and a disclaimer that it's not really autonomous, right? It requires human oversight. And I don't think that message is being properly appreciated by some people, and nor is it being appreciated why, in fact, that message needs to be taken more seriously. And so you could imagine interventions there, right, which would sort of make it the case that the ethicality of releasing this product and saying, oh yeah, some people are going to die, but fewer people will die in our cars than die in other cars. I think that I think that's an inappropriate response, because if there's a way to reduce those kinds of accidents even further by having better informed, better educated users, then one has an ethical obligation to do that. And one more thing to say about that is that that it's not just the owner of the car who's at risk in this, right? It's other people around. So the woman who got run over in Tempe, Arizona, didn't know that a self-driving car was approaching her. Maybe if that thing had a flashing light on its roof saying, "Hey, I'm a self-driving car," she would not have crossed in front of it the way that she did, on the assumption that she was safe to do so. So in the old days when cars were first introduced, there was places had laws that somebody had to walk in front of it waving a red flag, right? It seems to me that we ought to be flagging that you, as a non-user of this vehicle, are nevertheless interacting with something that is not being controlled by a human being. And therefore, while it might have a lower chance of running you over, the way in which it's going to run you over is not the way in which a human would run you over. And so you actually need to think about what you're doing in front, be a little bit more cautious in certain ways in front of this thing. So these are ways in which I think people in the tech industry in particular need to think much more globally and holistically about not just the product and what its capabilities are, but the entire system in which it's embedded.
Absolutely. Yeah, I think you're right. I mean, having the right expertise, also the right people with the experience of being affected by the sort of technology that's coming down the pike. All these things need to be taken into consideration, or to get the right fault tolerance, the right resiliency, the right graceful degradation built in and thought about, not as afterthoughts or bolt-ons, but as, something as built into the original project, and, the right governance principles as well, right?
Exactly.
It's all important. It's got to be built from the ground up, from these sort of perspectives, informing the right design decisions from the ground up, instead of just, you're right, absolutely. Look, it's been fabulous talking to you. I've wanted to do it for quite a long time. I just mustered the courage recently. But yes, so much. You've been involved in so many very highly impactful projects. You've written about so many really great things. It's really great what you do. Keep it up.
Well, thank you. And I really appreciate.
As long as you can.
Well, thank you. Yeah, and I also really appreciate that you have taken you've thought about this a lot, and you've taken the care to read the book carefully and ask such great questions. It makes the interview so much more fun. So thank you for that.
Oh, no problem. And I appreciate you spend the time. It's been, yeah, look, this is an opportunity for me, so, why not engage
Great.
with the
Yeah, we're in
material,
the same time
understand it,
zone briefly. Yeah, so very
Yeah,
good.
yeah,
Yeah,
that's true. That's true. That's
yeah,
true.
yeah.
Yeah, and thanks for everybody for tuning in and listening. Please subscribe and share this video.